Hello everyone, today is February 15th, 2022, and back to the the problem I am working on is median of the two-sorted array. So basically that's two-sorted array numbers 1, numbers 2, set m and 2mn respectively. Return the median with the twos. So that required log m plus n. So since that requires binary search strategy, basically that's for example 1, 2, and 2. So that basically return the float as a 2. Second one will be the 1, 2, 3, 4, and return 2 plus 3 divided by 2, since 2 and 3 are in the middle. Restrict the two arrays could be zero length, and but both together, that means at least one array has one element. So the numbers range are like this. So basically, I am thinking, okay, so in basically the solution will be the merge sort. So just merge two arrays together to the one and check the middle. So that will be the solution. But since that's binary search, I'm thinking to search the middle in each array at same time. So I have the right partition function right here. So that partition will check the different way to make sure. Okay, to make sure any array has the right partition. That means, for example, if the two array is like this, so we will make sure, for example, we search that one, so we will make sure all the, index 1 and index 2 here, all the the left items are less than the right items, whatever if there is left right item exists or not. So that means my logic will be the maximum of 2 left will be less and equal than the minimum of right items. So that's my logic. So to cover the corner cases, I also handle the 0. Made index is 0. In this case, I just convert all the index to the one index array. So that means I'll handle, so for some cases, the index will be right here. So that means present as 0. That means 0, element selected into the merge array. So that will be the 0 index. So, okay, basically that will be I handled some corner case right here for the either array has 0 elements, size 0, and after that I start the two set of index to indicate array 1 and array 2 to handle all these things. Once we just start with made 1 and made 2, and we just searching the right partition in the while loop. And when the right partition is here, so I just check if the length select from array 1 and the plus length select from the array 2 equals the target. That target is the number, the 2 array size divided by 2 plus 1. Since that's 0 index, I just plus 2 plus 1. And I also check that is odd number or even number to get a different return. Let's handle some corner case right here. If the select length is less than the target, which we just moving right forward, right side, and that's on each step I just move one step on either of array, depends on the indexed elements which is bigger, and which is smaller to move right. On the else branch, I just do the same things, so I will move backward left side one step on the smaller element of the array. Okay, and so for the while loop and all this logic, I tried some test case right here offline, but I I was struggling for the logic. But when I handled all logic, I noticed there's one case right here. My logic, my design doesn't cover that case. So, for example, 1, 2, and minus 1 and 3. So, okay, my minus 1. So the right index will be here and here. So all the left is less than 3, that's fine. And the made 1 is 2, and the made 2 is 1. So 1 plus 2 equals 2 equals 3. That's the right partition. But as my logic, that will be get this one and this one. It's not right. We need to check this one also. And I'm thinking, so to cover this case, I'm thinking another way to have maybe a global variable to store the two more biggest, top two biggest element at the left side of the index. So we could do some storage right here in the right partition to make the logic more clear. But based on that, okay, I could do some, logic right here to handle the case. Okay, to handle the case which top two biggest elements exist in same array. Okay, so we just return equals double yeah. I'm thinking I could use max or min function to check, but no. Yeah, I could do this way, so max numbers made 1 minus 1 and made 2 numbers 2 made 2 no, that's not right. So let me add the basic logic here so I could organize. I could if numbers made 1 minus 1 greater than numbers 2 made 2 minus 1. Okay, then return equals double max numbers 1 numbers 1 made 1 minus 1 plus max numbers made 2 minus 1 f made 1 minus 1 greater than 0, and numbers 1 made 1 minus 2, 0. Okay, that's the case. So I try to, so if this is bigger, so I just add this one plus the max one for that one. Between this one and the potential, the left element of this one, the made 1 minus 1. That happens when the made 1 minus 1 greater than 0. Okay, else. Okay, when then we just add 2 minus made 1, made 2 minus 2, and the maximum number 1, and made 2 minus 1 greater than 0. We just made 2, numbers 2 made 2 minus 2. Okay, that will cover the case in this logic. Let me write the test case again. Okay, and check this error case again. Run the code. Oh dear, that's right. Let me submit again. Uh-oh. Let me check how many test cases I passed already. Oh, that's 2,000 test cases? Oh dear. Okay, so that's the 1, and that's reached to 3. I copy the output to the other windows and back. So finally I reach here, I'm 1, 0, and 3. 0 S3, that means we don't take anything from first array. That's because that's only okay, so that's because that's the number 4, that's right. So, and the right partition, if there's, okay, that's the 0 things. Since that's the 0, since that made 1 is 0, so that's just return the true. And since that will be 0 plus 3, that's 3, and the target 2, so that's equal. And since that's the 4 elements, we go this branch. Okay, let me check. So the 0, oh, okay, in that case, we also need to handle the 0 here. Yeah, oh, that's really complicated. I doubt this is not the right approach for this support, but let me check. Y paste 5 lines, this right here. Else if made 0 equals 0, so return will be double. Copy this line is better. Double 2 and double. So that will be the double 2 2. Double 1. Okay, let me try that case again. Let's cover the corner case again. And I copy here. I got right answer. Let me submit. Runtime, let me check how many I have passed. 60. That's far, far way ago. Okay, that's converse. That's converse. So we should go there branch. Why that happens? So that's M2 is 0. Yeah, M2 is 0. And we just access one. Oh, okay. That's a tuple. That's a logic tuple. Okay, that doesn't matter. Submit. Runtime error. Okay, another case. Let's cover that case, right? We covered that case. So that will be 0, 4, 0 plus 4. Okay, the target, why the target is 2? Okay, target is 2. Okay, then 4 greater than made 1 plus made 2. greater than target index plus 1. Okay, that's greater than that one, so we will check. Okay. Oh, it seems we could handle the case here for the 0. Okay. So, okay. Basically, in my logic, I will handle the case right here equals the 1 greater than 1, but each branch has to handle the made 1 equals 0 or not. So in that case, it seems we could move the 0 index out of that one. Just that will be much clearer. So I'm going to change the logic next time. I think today I will pause and we'll keep working on later on tomorrow.